when we calculate cell potential Ecell is a measurement of the difference of the two reduction potentials. It's always written as E of the reduction minus E of the oxidation. E of the anode minus E of the cathode minus E of the anode. When we look at the cell potentials, all of them are given as a reduction potential. And so we have to use our values to help us determine that. Use our values from the table to figure out which one, this guy, if they're given as a reduction potential, they appear identically as we expect. If they appear opposite of that, they're going to appear in the reverse. So like hypothetically, let's do equation Fe2 goes to Fe3 plus, and Cu plus goes to Cu solid. Now, let's just say because how we did it, well, don't need it. So looking at this, I'd look at my table and find Fe2 to Fe3. Find right here Fe3 to Fe2. Fe3 to Fe2 is 0.77. To Fe2 plus electron is 0.77. Now copper 1 to copper solid. Scrolling down. It's copper 2 to copper solid. I assume I have it on here, but maybe I don't. That's copper 2 to copper 1. Guess we'll have to. I have it on a different table. Copper 1 to copper solid is 0.521. So we'll just use that. 0.521. So typically, a spontaneous reaction would be positive Ecell. However, if you're given a reaction and told how it's supposed to go, you must always solve for the value of what you're actually measuring. So in this case, it'd be 0.521 minus 0.77, and that'd give us our negative voltage. 1.7. So negative 0.249 volts. If you're given this in cell notation, it's just as simple. If I have, for example, let's see, let's do copper, Cu2 plus notation. Let's see, Ag plus Ag. So the way you read this is from left to right. Copper is going from copper 2 plus, silver is going to silver plus 1. So I need to find what is this guy. What is this guy? Cu2 plus. Once again, I'm those electrons. This guy, the reverse of this is 0.5 0.15 volts. The reverse, copper 2 plus 2 electrons, is 0.15 volts. Silver, Ag, plus 1 electron, Ag solid, is, I think if I'm reading it right, 0.8 volts. 0.8 volts. Now, here's the beauty of this. These values are irregardless of the number of electrons transferred. We do not care that this is 1 electron and it's 2 electrons. We just say 0.8 minus 0.15. So you'd get 0.65 volts as your value. The E is already been, the voltage has already been adjusted for the electron transfer. So we don't have to double 8. We don't have to double that up. It's just literally the subtraction of the reduction minus the oxidation. That's how we always do it. We always do it. Subtract the oxidation from the reduction. Subtract the anode from the cathode. So with that in mind, that must be our cathode. That must be our anode. The battery is typically written anode first, then cathode. So that is how we would determine cell potential. That is the easiest thing to do. But you have to find the matching half reaction. Don't be confused. Don't get copper 1 to copper 2 plus. Don't get copper 0 to copper 1. You have to get copper 0 to copper 2 plus. You have to find that half reaction to make it work. So make sure you find the correct matching half reactions to find the voltage.